going to talk about SocketIO. It's an open source project for enabling WebSocket and making real-time applications easy to make on every browser and every mobile device that we can make it work on. So my name is Guillermo Rauch. I'm the CTO and co-founder of an education startup in San Francisco. We have a big commitment to open source, and I spent part of my time developing this technology. I've been heavily involved with Node.js since it appeared. I originally developed a standalone WebSocket server that of course would only work with WebSocket clients. And then I saw the opportunity of making WebSocket work on more than just cutting-edge browsers. I'm also a core modules developer. I've been working on client-side JavaScript for a while. And those are my, if you want to reach out or fork any of my projects, you can go to GitHub or follow me on Twitter or find me on Freenode. So SocketIO is actually two projects. There's a SocketIO client that of course runs on the browser. It uses feature detection to decide how to establish a real-time communication to the server, depending on the user agent capabilities. And an officially supported SocketIO Node web server. There are some projects that are trying to make SocketIO work also on other stacks, such as Erlang, Python with Tornado, Twisted, even Google Go. So you can go to the SocketIO website to learn more about those. So the client-side API looks, I don't know if you guys are familiar with WebSocket, but I'm going to go into it later. The API that you instantiate from the client looks pretty much like WebSocket. It does more than WebSocket, which is necessary for creating real-time applications. The premise is that it works on every browser, so you're not concerned about compatibility. And it's lightweight. It's only 10 kilobytes when compressed. I'm going to talk a little bit about the real-time web and what I mean when I talk about real-time web applications. When we talk about real-time web applications, there are many terms that come to mind and that have been popularized over the years, such as the Bayou protocol, Comet, this premise of server push, server sending data to the client, which is reversing the request response model. Now there's WebSocket and all other protocols like XMPP. So what is which? I'm going to start by describing a really simple real-time application. A Twitter client that fetches Node.js tweets as they are pushed by Twitterers, and you might wish to display the tweets on your website. So the first approach that would come to mind for most people is just making AJAX requests every 5 seconds, right? So you could use set interval, and with a light jQuery call, you can get data from the server to the client in pseudo real time. Of course, the problem is that you're only getting data 5 seconds at a time, and whatever happens in the middle, you're not showing instantly, or you're not showing to the user as frequently as you could wish. So the next approach that would come to mind would be making an AJAX call and that asks the server, is there any data, are there any tweets for me? And if there is, show them. If there is not, initiate another AJAX request. But that approach has two major flaws. One is that taking into consideration the HTTP latency and download time. The best case scenario for that is that it might take 500 milliseconds between AJAX requests where the client is basically disconnected. And another problem is that we're increasing network traffic, but the server might not have any tweets for us, might not have any data. So we're basically asking the server a lot, generating a lot of calls for, and we're not sure if there is going to be data there. So the first solution to this problem is called long polling. It's not actual server push, but it does a pretty good job for most of the use cases, because what it does is it opens the connection, and if there's no data for us, it keeps it open for a number of seconds, like 20 seconds. It effectively decreases latency and network traffic. And another advantage of this approach is that it pretty much works on every browser. If you're using jQuery to make the call or any other JavaScript framework, you're enabling your application to make a real-time call without any overhead or incompatibilities. Of course, it also has weaknesses. If there's a lot of data for us, then the long polling loop will be effectively closing and opening connections all the time. So we're back at our second approach, which was calling the HS, creating another HS call when one finished. So again, we're hitting latency and network traffic problems. So the solution that makes the most sense would be keeping the connection open. And there are solutions for this. Two pretty common ones are opening an iframe and not closing it, and get a script tags that are executed when there's data. And another one, a little bit less known but supported by Firefox, is the multi-part XMixed replace content type. Essentially, it's a normal XML HTTP request object that is created by passing the multi-part flag, and it sends us messages with boundaries. So the server has to say, okay, here's a message, the boundary, some delimiter message, and the connection is open and we're getting data all the time. The hidden iframe also has implementation differences. We have to make sure we send the connection, keep alive header, transfer encoding chunked. Those are HTTP headers that we have to send. And as an user experience problem, what happens when you just open an iframe that is injected into a DOM is that many browsers are going to show the progress bar as if the page never loaded. So the user will be met with a progress bar that is like he's not sure what's going on really. There is a solution for this which is implemented by SocketIO on Internet Explorer, discovered and popularized by the Gmail team when they created Gmail chat, which is hiding this iframe, injecting it into a pseudo document, which is an ActiveX HTML file component. That effectively hides the spinners and progress bars. So these are two transports that we can leverage to make real-time communication possible. Of course, for certain browsers, and the server has to behave differently depending on which transport is used. So these techniques are there. They vary by user agent. They're only for incoming data. So when you open that iframe and you need to send data to a server, in order to have bidirectional communication, you still have to use regular AJAX. So the solution by the web standards people is called WebSocket. So you shouldn't be needing to struggle with all these limitations. We need a protocol that enables bidirectional communication out of the box with a simple API. If you guys read the spec, this is the basic description, and simplicity is one of the core goals of this protocol. The way that it works at an HTTP level is that it upgrades the connection. HTTP 1.1 supports this upgrade header that basically says, at this point, we're not doing a normal HTTP communication. We're upgrading it to a new protocol, in this case, the WebSocket protocol. Again, the server has to react to this response by doing several things during the handshake process. Draft 76, the new draft of WebSocket, introduced a security mechanism. It has a fairly unique framing system It does UTF-8 for the encoding, no binary support, and of course it's only supported by cutting-edge browsers. And it's still ongoing, constant changes. It's pretty much a work in progress. But again, one of the advantages is that WebSocket is really simple. Basically, we declare, we connect to the server with the WS schema, and we have 3 event handlers. Actually 4, there's on error. When that notifies us when the connection is open, when a message is received, and when the connection is gracefully closed. So, considering the state of WebSocket today, let's think about cross-browser support. When we do Ajax today, like I described earlier, we're used to using some abstraction of XML HTTP request, which also gives us compatibility, for example, with IE6 by leveraging the ActiveX object that Microsoft created back in the day. These kind of APIs make it simpler to achieve the goal of making an asynchronous request to the server. And they also add new features. In the case of jQuery, we now have support for timeouts, caching, filters, depending on the content type of the response. And again, the entire goal is that we're making Ajax simpler to use. And SocketIO has a really similar goal. So we're abstracting away all these transports. It's not just WebSocket. We can also use Flash if available. We can use long polling. We can use multi-part Ajax iframes. And it all depends on what user agent is trying to connect to the server. So far, SocketIO has been tested on IE 5.5 with different transports like Flash and HTML file, Safari 3, Chrome, Opera, and mobile devices. It again adds new features. So, for example, when you open a WebSocket connection, the close event will only be fired if the connection is closed appropriately. If the server dies or the client internet connection has issues, that close event will never fire. So even though the API is simple, we still have limitations when we really need to create a functional real-world real-time application. We're trying to do what all these frameworks did for Ajax, we're trying to do for real-time communication. So far, the project has been successfully deployed to production in many cases. If you guys follow the Node Knockout competition, many people have created real-time games and other kinds of real-time applications with it, and there is a lot of community interest on GitHub. But one thing to keep in mind is that SocketIO is just a building block. SocketIO is protocol agnostic. SocketIO, you can send JSON and on the client side interpret it and do something, or you can connect and implement the IRC protocol, for example, and you can create an IRC client and speak the IRC idioms. Again, SocketIO is just a building block. Creating real-time applications is not trivial. There's many different protocols and many different ways to do it. And a game is significantly different from making certain things in your regular web application real-time. I created this project that leverages SocketIO called Nostream. The goal of Nostream is being the protocol for the most common use cases for your web applications. As an example, I created a really simple to-do list application on Node.js. So again, this is a regular web application that interfaces with a database and displays the to-do list items that you have to complete, and it allows you to add new items. Every time we add something, the page is refreshed, and we can edit, right? So even though this is a really simple application, it still has many flaws for the users. The first one is that what happens when you open two tabs of two instances of your application and you decide to delete an item? All of a sudden, this page has 2 items. This page has 3. It ends up hurting the user experience in this particular case. But what happens if more than one person are trying to use this, this application? So I'm going to quickly show what the code looks like to create this application for those not familiar with Node.js. I'm defining a model. I'm using the Express Web Framework to define some routes, like edit, add, delete, and I call the database and I remove the items, add the items, respectively. And then what I send to the client is a redirect. And this is what we're trying to change with Nostream. So I'm going to show you what the real-time version of this to-do list looks like. In this case, we're attaching SocketIO to the web server. And it has 2 new features. First, we're displaying who is editing, and now we're making all the interactions that I described through the routes, we're making them real time. So what happens when I open a new tab is that all of a sudden they're all the same, and we can take it to a new level, and we can try out different browsers. It's interesting to see that Safari 5, of course, is connecting to SocketIO through WebSocket because it's the best transport that SocketIO can find. What happens when I go to Firefox is that it's going to use multipart. Like I described, this process is completely transparent to the developer, and again, we are effectively enabling real-time collaboration across users. If I close one tab, the counter will change. Now, the really interesting part about Nostream is that all these features have been created by only doing 2 things. One is firing events when certain actions happen, which it's a great fit for Node.js, of course. And the other thing is that I'm only telling the template language what things to update. So this is what the template language looks like. This is similar to Haml. It's called Jade. This is the page for our old to-do application, the traditional one. I get the items, I go through them, and I show a piece of template. Now, in the real-time version, all I do is declare a part of the template as real time. I tell it this piece of template is real time, and it will repaint whenever the connections event is fired, and the variable will be called connections. Say again? Oh, I'm sorry. Oh. Not quite. Any suggestions? Lazy? Oh, lazy is good. No pun intended. Again, I simply replace that for each loop with this real-time filter. And I'm indicating it that it'll append new items when the new event is fired, it'll repaint when edit is fired, and it'll remove when the remove event is fired. And all I have to do from my application is fire those events. So instead of redirecting the user, I'm just sending a 200 response, and emitting this event. So what happens is that the user, you as a developer are simply making an AJAX call that triggers that event, and through the real-time socket, we fire the changes. So not only has the neat effect of making your application real-time, it also makes the client-side code simpler, because we're no longer making an AJAX request that returns some HTML and then we decide to inject it somewhere. It all happens transparently from the client-side point of view. So that's Nostream. Again, it uses SocketIO as a building block to enable it to work on every browser, including mobile devices. And you can find this particular example at my GitHub page, JSConf.eu demo. That's it. Thank you. Any questions?
The various techniques that you use probably have different size constraints of the message that can be sent over the web, right? Does the library somehow handle this, or do you just do what WebSocket allows? Like the most common device for the web?
So yeah, the differences between transports, including the ones related to message length, are taken care of by SocketIO. So when you're leveraging it, you're not concerned at all with how the inherent limitations of the transport. So SocketIO has a very thin protocol that is, of course, hidden from the user, which is required, for example, for long polling. So in long polling, the client is opening and closing connections, but the server might want to send messages during that disconnection period. So we need a protocol that says, okay, this long polling client has a session ID and will buffer messages for him on the server side. And when he reconnects, we're saying, that protocol is saying, okay, you have 10 messages, so you have to fire 10 message events. And the transport also takes care of saying, okay, the message length is this, and if the client can check, okay, is the entire message here, otherwise it'll wait for more data. Correct. I'm gonna open source it right away.
Question is on the, how far do you require on Node.js on the server? You said there is some kind of Python support. Is it also true for this Nostream notification?
Nostream is entirely based on Node.js technologies. So right now it works with a specific template language created for Node, but it wouldn't be too difficult to make it work with more. And again, the server-side part of SocketIO itself, the protocol is documented and it can be implemented on any backend. And again, the client-side part of Nostream can also be leveraged for any implementation that speaks the Nostream protocol.
Do you plan to make SocketIO a proper connection to it? So right now you put it standalone and uses
Yeah. So Connect is a framework that is geared towards request response cycles. So making SocketIO middleware in that regard would be extremely difficult, and we would have to actually change how Connect middleware is defined. But what I'm working on is a session connect and the ability for easy identification of SocketIO clients to the session of your website. So if you're leveraging the session component in Connect, you probably have some like database data associated to that session because the user might be logged in, and making that easy to retrieve from SocketIO is certainly one of my goals, but also make it compatible with any other session mechanisms that you might be using, not just connect and the session middleware. Yep.
So WebSockets still has support for binary data, right?
No.
But you could apply binary data if you make 64 input.
Correct. Yeah, and SocketIO would totally support that. Yep. All right. Thank you.